Welcome to Gerima. It's nice that you've turned into our channel. Today, I want to give you 5 tips on how to increase the service life of carbide inserts on our hand milling machines. Tip number 1, preparatory work using an angle grinder. We don't want to do the job of our milling machine using an angle grinder. That would mean taking a step backwards. But for plasma and laser cut materials, it is advantageous to deburr the edge using a grinding disc to protect our inserts. As you probably know, special plasma cut material is much harder on the exterior than in its core. As a result, we have a very hard edge right where the insert penetrates it. By using this trick, we can increase the tool life by up to 50% in mere seconds. Beveling by a mere 0.5 mm is enough to neutralize this hard edge. This enables the insert to penetrate more gently and last much longer. Tip number 2, the correct feed speed. We always try to maintain a feed speed of at least 1 meter per minute. If the feed speed falls below this level, the plates keep grinding in one position so they don't get cooled down by new chips. The inserts heat up and the coating gets burnt. Therefore, after slowly penetrating the material, we should increase the feed to 1 meter per minute. If that's not possible, using normal force, we have to reduce the bevel width and work with a second stroke. Now first let's see how not to do it. The inserts will be used up after a third or after half the distance that could be processed using a faster feed rate. Or maybe even sooner, judging from the flying sparks, which indicate that the cutting temperature is too high and this destroys the coating too. Now let's see the difference employing sufficient feed . You see considerably fewer flying sparks, always a good sign. The color of the chips also shows us whether we're on the right track. The lighter the chips are, the longer the tool life that the inserts will be. Tip 3, in order to increase the tool life of the inserts even more, we also have to monitor them. We should try to replace single inserts the moment they show signs of wear. If you wait until all inserts on the milling head are worn out, the total operating capacity of the tool set will be less than if you immediately turn the blunt insert, protecting the other inserts of the milling head against overload. Here's an example of a new insert and one that should be replaced. If I detect this attrition and react accordingly, the downstream blades will be able to work longer. Tip 4, speed control. One of the most important ways to optimize the tool life of the inserts is to choose the right spindle speed. The material and the application provide initial orientation. Level 6, that's full speed, is for aluminium, copper, and softer non-metallic materials. For normal steel, we work mainly at level 5, and for stainless steel and fine-grained steel, we carefully have to see how slow we can make the milling speed for our application. The goal here is to make it as slow as possible while avoiding strong vibrations and impact. If the milling process becomes rough, or if we no longer get the kind of feed I explained before, we go back and increase the spindle speed by 1 step. If we no longer produce a smooth milling process due to low speed, we'll get the opposite effect of what we want. We will forfeit sustainable tool life. For this reason, only reduce speed as far as you can and avoid vibrations. And tip number 5. For stainless steel, fine-grained steel and other high-strength materials, we should enhance the milling process using lubrication. Put a thin line of grease on the edge every 30 to 40 centimeters. This will be picked up by the inserts during the milling process, providing additional cooling and lubrication. In particular, milling processes involving stainless steel generate a lot more heat. This burns the coating on our inserts, shortening their tool life considerably. Therefore, as a last tip, lubrication. So, thank you. These were the most important tips for extending the tool life of your milling inserts. Please tell me if they were of any help to you and what you use your Gerima machine for. Tell me which model you have, which inserts you use and which materials you work with. Maybe we can have a little discussion about optimizing your process so you can get more meters out of your equipment. Thanks for watching. If the video helped you, please give me a like. I look forward to our next video session.